Well, I have to go back to time when I was a schoolboy. And at that time in Poland, well, we had primary school and secondary school. So primary school was between 7 and 15. So eight grades. And I was quite good in mathematics, but what was more important was the fact that we had a very good teacher. So she really took care of best pupils, and we had some additional classes. We were well prepared to take part in competitions. So I took part in many local mathematical competitions, always being, well, either the first or the second. So I really liked it. And I remember that, when I was in the last grade, so I was already 15, so somehow they even asked me, so teachers, they asked me to have classes with younger pupils. But this has changed when I changed the school and the secondary school, so somehow I stopped taking part in competitions. I had a very good professor, because we were calling them professors in the secondary school. I had a very good professor in mathematics, but he somehow didn't take care of pupils so much. He was a strong personality, very original man. But somehow, well, he had no patience, just to train pupils. And so as I said, I stopped taking part in competitions. Somehow I used to play chess for some years seriously, and some sport. That's when you are a teenager. It was between 15 and 19 years old. So finally, when the last grade came, so I decided to become an engineer. Already my two older sisters, they were engineers. My father was an engineer, so I just thought I would be one more engineer in the family. But what happened, it was just a few months before the secondary school leaving exam, what in French is called baccalaureate, that this professor in mathematics, he brought me a letter. It was from a local committee of Polish mathematical Olympiads, and he gave me these problems. And I remember that then I asked my older sister to explain to me some notation, mathematical notation I was not familiar with at that time. So she did, and somehow one evening I solved all these problems, and I just sent them to the committee, and I forgot about the story. But a few weeks later, a letter came that, well, you're qualified to, let's say, semi-final of this mathematical Olympiad, and I went to Torun. I went to Torun, to Nicholas Copernicus University. I was 19 years old, and well, so all this event was so important for me that I decided, well, I have to do something with that, and I decided that I will be studying mathematics. Yes, so this was a little bit later, because when I started my study in mathematics, so I was among the best students, first year, the second year, but still, but maybe I was as a young person, I was under influence of my secondary school math professor, and somehow I thought maybe I should be also, a teacher, a good teacher, But this has changed really when I was on the third year student, and then I somehow decided I want to be a professional mathematician. So in fact, so there was a third year, and I decided to take more courses, more classes, and professors, they liked this idea, and they let me finish my study in 4 years instead of much longer period. And this was a very dramatic period in Poland. We are in 1980, 1981, so the first solidarity, and in fact the first encounter with freedom. So this was very important, and because somehow I shortened my studies, so I defended my master thesis in time. It was just before the martial law in Poland was imposed. So my colleagues, they were not so much lucky because of all these perturbations, which this martial law caused in Poland. So they studied 1 year more. And when I became assistant professor at the university, so I had even classes with them. Oh, rather late, I think. But I have to come back to my secondary school then. As I told you, that there was just a few months before this final exam, I decided that I want to study mathematics, and this final exam, baccalaureate, was a serious one, and there was a written part and the oral part, and the oral part was possible to replace if you write a thesis. So you're in the secondary school, and there was a possibility to write a thesis on, well, choose a subject. So I chose something about the notion of being countable set. And so this was very abstract to me when I started reading, because, well, of course, in primary school, secondary school, you have easier and more difficult problems, but somehow you get used to them. But this one was very abstract. And I remember that one day when I understood why the set of polynomials with rational coefficients is countable, I really felt like somebody who is initiated, well, I saw the proof. Yes, so I graduated in a sense from algebra and logic. My master thesis was in algebra and logic, and that my first publications also in this domain. But then I changed completely my domain, and I am a representative of ergodic theory. And ergodic theory is a part of the theory of dynamical systems. But as such, ergodic theory touches many other domains. Well, in fact, its origins are in statistical physics. Then you cannot avoid spectral theory, operator theory. You have to think, you have to know the probability theory. In fact, well, for example, Jerusalem School, they view ergodic theory as some sort of moving probability theory. I'm just talking about the theory of stationary processes. So in ergodic theory, I focused on spectral theory. Then somehow I learned the theory of Gaussian systems, and more generally on the theory of dynamical systems of probabilistic origin. And definitely I am a specialist in what is called the joining theory of dynamical systems. These last years, let's say 4 or 5 years, I am very much influenced, or my research is very much influenced by some interactions between ergodic theory and number theory. I think here about so-called Möbius disjointness. This is connected with a conjecture formulated by Peter Sarnark in 2010. And in fact, the whole program which I proposed here for this semester is around this conjecture. Okay, so somehow you can divide these reasons into 2 parts, or let's say strictly professional reasons. I'm talking about my research, and then some, well, let's say some human factor, but let's talk about it later. So as for mathematics, as I told you, I became interested and really involved in so-called Möbius disjointness. So, of course, interactions between ergodic theory and number theory were known before, and they were somehow, maybe first they were seen in a really spectacular way in so-called homogeneous dynamics. So that there are famous names like Margulis, recently, who was a Fields Medal laureate, and recently Alon Lindenstrauss also is a representative of this part of the theory of dynamical systems. So Lindenstrauss received the Fields Medal in 2008 or 2010. So then this was well known, and then also in the late 70s, Hilaire Furstenberg, he proposed a new kind of interactions between ergodic theory and number theory, maybe number theory and combinatorics, which is, so here the idea is that somehow you look at subsets of integers, and these subsets are sufficiently large, so let's say they have upper Banach density positive, and somehow you look at the relations of what kind of configurations you can have in such sets. So this was this famous proof of Furstenberg of Semeredi theorem on arithmetic progressions, and then all this approach was, let's say, formalized by Furstenberg transference principle, which more or less says that if you have some interactions between large sets of integers, so in fact these are exactly ergodic theorems in this abstract theory of dynamical systems. So this was known, and these are both very flourishing areas. But in 2010, so Peter Sarnark, he proposed one more kind of interactions different from the previous two ones. And this time it's just a sort of question that you have the Möbius function, and the Möbius function, the arithmetical Möbius function is a very important function in number theory, just explaining what's happening with prime number theorem. Even some formulations, some properties of the Möbius function, they are equivalent to Riemann hypothesis. And the Möbius function is considered as a random function. And well, of course, in number theory they understood this phenomenon, and they somehow formalized this by saying, okay, it is random, so it should be orthogonal to anything which is, in a sense, which is not random, which somehow it's deterministic, but it has never been phrased in a clear way. So what Sarnark proposed is that, well, look at all observables in dynamical systems, and these observables, they are deterministic, which is phrased clearly because that's the concept of entropy. And now check if you are really orthogonal to the Möbius function. So of course, if you look at such a formulation, you may think, well, that's a question, maybe I like it or I don't like it. But if you are especially, after some time, especially for somebody like me who spent a significant part of my life in ergodic theory, it's clear that this conjecture is related to the joining theory of dynamical systems. So, and as I told you, joining theory is one of my specialties, my domains. So I thought, well, why not? Why not to think about it? And the more that it turned out that this conjecture somehow influenced ergodic theory itself, and it caused many interesting questions in ergodic theory itself. So that's what I'm doing, and that's what I proposed as the program of this semester. So, but that's somehow purely mathematical reason. But there was another one, which is the fact that in Marseille there is a very strong group in number theory. And in the past, I closely collaborated with Christian Mauduit. So in the late 80s, and in the beginning of the 90s, we wrote 3 joint papers. And I know that they also think about the Sarnark's conjecture, maybe from a different perspective. So when they learned that I am also interested in that, they somehow proposed me, well, why not to try, to work together on that? So this was, I think, maybe the main reason I really applied for the chair. Yes, so in fact we just began research in Perth. So the first visitor was Gerhard Keller from Erlangen, with whom we somehow thought and we worked on so-called B-free systems and with interactions with if-Meyer theory of model sets. Then Sasha Danilenko from Kharkov came, but here we work on a project which is closer to classical ergodic theory. We think about Bernoulli shifts in non-singular world. Then Jean-Pierre Cons is now here, with whom we are working on some problems related or originated by Ratner's property. Then there are two mathematicians from Bielefeld, or there were maybe two mathematicians from Bielefeld, Michael Backe and Christian Hook, with whom we work on B-free systems, but in the context of lattices in more dimensional spaces. But that's research in pairs, and it will be continued at the end of this month. There are two mathematicians from Rouen, Hussein El Abdalawi and Thierry Delary, who are coming, and we planned to work on the validity of Sarnark's conjecture in strictly ergodic models of discrete spectrum automorphism. This is what I proposed in my program, but the program was written 2 years ago, and the life is as it is. I mean, and we learned a few weeks ago that in fact this problem has been solved by a group of Chinese mathematicians. So we will be working on similar problems, but well, let's say not exactly the one which we planned on. So that's research in pairs, but then in October we will have two events. Next week we start a conference in spectral theory of dynamical systems, and this is followed by a school, by a doctoral school, and in this school we will have 4 mini courses. So one by Vitaly Bergelson, who will speak about interactions between ergodic theory and combinatorics, mutually enriching interactions between these two domains. Then Joël Riva will have a course which is an introduction to analytic number theory. Manfred Einsiedler will speak about homogeneous dynamics. Carlos Mateus will speak about problems in Diophantine approximation. I mean, it all happens now in October. It's a very, very hectic period, and well, I'm really overwhelmed. But then there will be November will be without events, and in December we will have 2 events. So, which is a workshop on Möbius disjointness I mentioned before, and finally the main conference, which will be in the second half of December on interactions between ergodic theory and number theory. Okay, so I think that mainly people, right? People are coming. You can work with people, you can discuss with people, you exchange ideas, you can learn proofs, techniques, and so if you look at the number of registered participants from Marseille, so it's really huge. I think that it's really they like what is proposed by the semester, and for me, I would say, well, that's the best place. Marseille, Cirm, that's the best place where I can realize the program which I really proposed. As I told you, I wrote this program 2 years ago, but of course that's a very active domain, so there are changes. And when I thought at the beginning that the Sarnark's conjecture is a very interesting and very influential idea which somehow helps to develop ergodic theory itself. So now I would say that even I am more convinced about that. There are some recent papers on that subject, and I was very much impressed by a recent result by Terence Tao, who proved that Sarnark's conjecture in a sense is equivalent to Chaulla conjecture in number theory if you make some additional assumption for the moment, but I mean, you just change the kind of averaging in this theory, so then it turns out that these two conjectures are equivalent. It is quite plausible that Sarnark's conjecture is equivalent to Chaulla conjecture. And Chaulla conjecture seems to be inaccessible. It's a conjecture from 1960s, and which is considered as one of the most difficult in number theory. So I think that somehow the subject is developing and just showing its maturity and its importance. I would say, well, these are events in December, because, well, the workshop, which is really focused on Möbius disjointment, we will gather all people who contributed to development or who worked on that conjecture these last years. And then we have the main conference in which, let's say, this homogeneous dynamics, combinatorics or combinatorial number theory, and people from dealing with Möbius disjointment will be present. And to see what's happening is that, well, the main conference, I looked yesterday at the number of people who registered, and it's about 120. 60 are accepted, and, well, the further 60 we have to do something. And still we have a few months. We are still before this event. So when the semester is over, I just come back to Nicolaus Copernicus University, and the next semester I will be teaching as everybody. But I have already invitations to interesting conferences. I will be in Oberwolfach soon, and there are some visitors coming. Jonathan Chaika is coming already in February. This year I am a laureate of a prestigious lecture of Władysław Orlich at Poznań University. So once I come back, I will have to go there and give this talk, which somehow was delayed because of Jean-Morlet's semester. So, well, nothing will change. I come back to the ordinary life of a university professor. Yeah, I find it the right place to work in peace. At the moment, I am there with my wife Barbara, and we like Chaire Jean-Morlet house, and it's really enjoyable. It's well equipped, and everything works perfectly there. So, if I can, I would like to recommend this place to all future holders of Chaire Jean-Morlet. And I would like to add that I like this idea that the holder of Chaire Jean-Morlet is on the campus. So one thing which is maybe inconvenient here, but this is independent of the Cirm, is that there are no shops in some reasonable proximity. But we came by car, so we don't see this problem. Well, first of all, I like the idea of a semester which is focused on one particular program. I think that is great, and to have an opportunity to realize such a program in 6 months, being free of teaching and having a possibility to invite people to organize events. I think that during such a period you can develop long-range collaboration. You can really see people, work with them, and of course there is for the holder maybe there is a little inconvenience that you have to organize these events, but, well, for me there is no problem. I really like it. I like this place. I think it's really a wonderful place to work, because when you look around, so you see really, or you can feel the scientific atmosphere. You can you can see people smiling, you can see people discussing, you have the staff, very professional staff, who's constantly smiling despite hard work they have to do, and it's very pleasant that you can go out for a while, you can look at Montpiget, and you can go to Calanques, and you can run, because I like to run, and you can walk. So I would say it's one of the best places I have ever visited if I really think about doing mathematics. You may think also that in such places as we are here at Cirm, that nothing is going to change, that people here, they somehow feel, okay, why should we look for some challenges, for some changes when everything goes so well? And I was very much impressed by the first meeting after vacations in September, where the director of the Cirm, Patrick Foulon, he told us about plans of changing the Cirm, of developing the Cirm, and I'm sure it will be appreciated by the international mathematical community.